Good afternoon, everyone. It's August 19th, Quake Weather Channel here with an update on the California earthquake situation we have going on today. So nothing major yet. The forecast that we put out yesterday remains the same. Not much has changed. I did want to go over some stuff though. So this was the coronal hole that we called out yesterday. A second one right behind it isn't very large, but in conjunction with this one could have a significant effect on seismicity planet-wide. This one was Earth-facing yesterday. The forces of it, the peak of which should be arriving here tonight and tomorrow, but then we have this one right behind it. So the watch period is probably going to be extended a little bit. If you look over here to the left, this area right here, we're not going to be able to tell right away, from at least not from this image, whether or not this is going to be a large trans-equatorial coronal hole, of which we would increase, the length of this watch period, but also probably the magnitude of the events that are going to occur would be larger. So something to keep an eye on there. Essentially, I'd say if this does turn into a coronal hole, this is just going to be like a really extended watch period. Typically, when we get coronal holes and we make forecasts here at Quake Weather, we only forecast for about 3 to 4 days, maybe 5. But when we get back-to-back coronal holes like this, you just do the simple math. Sometimes it lasts over a week. We like to stray away from that or avoid having long periods of, hey, for the next week and a half, we might have large earthquakes. It's kind of not, still somewhat helpful, but not as helpful and pointed and accurate as we'd like to be. As I usually like to compare to, make a comparison when I talk about these things is we forecast earthquakes and increased seismicity, and we could do it very accurately, actually. What we can't do is predict earthquakes. This is something people just can't do yet. So predicting an earthquake, you would have to give a very precise time and precise location of when an earth and where an earthquake is going to hit. It's like predicting a lightning strike. You can't predict a lightning strike and say, hey, at 11:45 a.m. on August 23rd, there will be a lightning bolt that strikes on the intersection of First Street and Main Street. Not likely going to happen. It's very highly unlikely, if not impossible, to predict a lightning strike. However, our weathermen and meteorologists can tell you, hey, there's going to be thunderstorms in this general region. And therefore, the chances of a lightning bolt striking somewhere in this region are much higher than usual. It's very similar with earthquakes, the way we forecast them here at Quake Weather. I can't tell you exactly with precision when and where a large earthquake is going to strike. What I can do with over 95% accuracy is give you a window of time where the frequency of earthquakes, meaning the amount of earthquakes that happen in a small window of time, is going to increase, and the magnitude of those earthquakes and volcanoes, by that extension, are going to occur. So I can tell you, hey, within this 2 to 3 day period, we are going to see an increase in the frequency of earthquakes globally, and the chance of getting a large magnitude earthquake, again, which we consider a 6 magnitude or higher, not 5 magnitude as you might assume, are going to increase as well. So giving the time window of when a large event is going to occur is relatively straightforward, and we're very accurate about that. Forecasting a location, a general region where the large events are going to occur, a little more complicated. Accuracy a little bit lower, probably I'd say in the 70 percentile range. We do get misses. It's not 100%. If it was 100%, I would be a millionaire, and this would be a part of your weather forecast every day when you watch the news or where, on your weather app or whatever. We're really close. Science is making some progress there. Pretty soon on the Quake Weather channel, we are going to be going over science papers that talk about the new findings that they have been, discovering over the last several years. But anyway, moving on. So these are the coronal holes. This might turn into one later. We'll check out another satellite in a minute to see whether or not this is a coronal hole, but let's just get moving here. Again, it's an extension of the southern solar polar field, which is of negative electromagnetic polarity. I'm sorry, positive. Green is positive. That's my mistake. So yesterday, when we were looking at low pressure cells, and again, we look for low pressure cells near plate boundaries. So, for example, there's low pressure cells here. I wouldn't forecast this as an area because there's no plate boundaries within a decent distance from here. I think like the nearest one would probably be the Mid-Atlantic Ridge, if not down here. I think they're almost, actually, no, it's closer to the Mid-Atlantic Ridge, but it's still, this is, a couple thousand miles, probably. So we look for low pressure cells near plate boundaries. So we don't have an overlay yet where we have plate boundaries and a low pressure cell wind map like we do here. So I kind of have to go off memory here. I know there's a large plate boundary coming here, cutting up over here, going into the ocean and up the Pacific Northwest up into Alaska. So yesterday there was a lot more purple here. And again, the gray is high pressure cells. So like over here to the left, this is a high pressure cell. Yellow is sort of in the middle. So this high pressure cell is feeding down into this yellow area. And then they come into these low pressure cells, which is the purple area. Yesterday, we had a lot of purple right here. There's a lot of low pressure cell activity. And our OLR anomaly data only had anomalies up in the Pacific Northwest. Not very strong, but something of note considering the low pressure cells and the coronal hole forces that we're experiencing right now. So a lot of the low pressure cell activity is gone from Southern California where we were looking at the clusters. However, this is the OLR. The OLR anomalies have almost cleared up. And again, it's such a disappointment that this is from the 18th. This is from yesterday. These maps are usually a day or two old, so they're not the most helpful because these things change location and they change strength a lot more rapidly than, in a 24-hour period or so. So not very helpful here, but not a lot of, there's almost no dark red anywhere. Actually, I don't see any dark red anywhere. So moving on, this is what I wanted to look at. So despite having no low pressure cells left, we are a little bit higher. We have more small earthquakes, and a lot of these are very tiny. So out of the 128 that we're showing on this map right here, I'd say, what is this about? Only a dozen or so are above 2.0 magnitude, and that's really not. We get earthquakes of this size all the time, all over the world. We get them here in California. A lot of times, I live here, my friends, family, everybody, you don't feel most of these. You really don't start feeling them around here until they're at 3 magnitude or higher, but even that's relatively low. However, the reason why I wanted to look at this and why I still kind of have my eye on Southern California is that if we zoom out a little bit, we still have the coronal holes that we discussed. We still have all those forces coming into Earth that we're going to be looking at over the next few days. But when we zoom out, we see something kind of interesting here. So this is all magnitudes. So there's a lot of, likely statistically irrelevant earthquakes going, because it's 1 magnitude or lower. But when we look globally, like this is the entire world, it's not common to see such a huge cluster right here in the United States, where everywhere else in the world doesn't have larger clusters. Usually you will see large clusters like this elsewhere. You'll see them down here in South America a lot. You'll see them over here in Fiji, Vanuatu, Papua New Guinea sometimes. You'll see them often in Japan. You'll see a lot of Alaska. I mean, the fact that we have like 10 times as many earthquake events in the past 24 hours in Southern California than we do Alaska, for example, maybe not too concerning, but that's pretty rare. That doesn't happen that much. So worldwide, in the past 24 hours, if you look up here, it's showing all the earthquakes in the last 24 hours. 215, right? Which actually isn't that many. That's actually really low. But when we zoom in here to California, we just zoom in there, more than half of those earthquakes globally have occurred here in California. and a little bit in Nevada, maybe down here into not quite Mexico. But if we zoom in even further, right, we go into this area, 25% of all the earthquakes we've had globally in the past 24 hours have been in Southern California alone. This area right here, when we looked yesterday, there were only a few, I think 4 or 5. All right, so if we zoom in just a little bit more to get rid of all that big cluster in Bakersfield, I mean, we've had 36 minor events just all along here, all along this plate right here. And this red line is a plate boundary right here. So here's a plate right here, one of the Earth's major plates, and this is the plate right next to it. And that's why we have the plate boundary right here, underneath there being the subduction zones. So a lot of activity here. Again, small activity, not the biggest concern, but because of the number and such a small period of time, and when you look at this in relation to everything else globally, it's interesting. I think, is this a precursor to a larger event? That's a good question. It would seem so. It would seem so. Now, if we order this instead of by largest magnitude, let's go to the newest ones first. One thing that can kind of, not necessarily because they're already small enough, because we're in such a small dynamic range of these events. This goes from newest first. So this is the most recent one. Sears Valley is where we had our last major 7 magnitude earthquake. Again, we forecasted that correctly 6 days before it happened. I did a big Facebook write-up about it. You guys can check out the Facebook page. It's Quake Weather. So some activity there. But what we're trying to look for is we're trying to see, okay, are these events over the last 24 hours, are they getting larger or are they getting smaller? So because these are in different areas, how about we zoom in where we're having a small, tight little cluster, which is right here in Bakersfield. So 2.5, 1.3, went right back up to 2.9. Then they've all been in the 1 magnitude since. So it looked like it was kind of wavering a little bit in this area right here. And then all the events that we had afterwards, wavering, but again, smaller than in that, 1.5 to 2.9 range or 1.3 to 2.9 range. And then we come down here and it's all, 0.9, which is like nothing, up to the 1.7 range. So it looks like they're getting smaller. That doesn't guarantee that we're in the clear. However, it does kind of make you want to lean towards that way, because if they're getting a little bit bigger, you don't know exactly when that increase in magnitude is going to peak and then start subsiding. If it's going downward, then you want to lean a little more towards, okay, maybe we've already hit peak magnitude range and we're starting to come down a little bit. But again, what's interesting is that Bakersfield had everything going on yesterday. And then today, there's just a bunch of tiny events going on here. So again, a little concerning, especially, again, if we go back, we got coronal holes. This one's going to start influencing us probably today. If it hasn't already, this might be why we're seeing a slight increase. And if it's just the beginning of it, we still have a few more days to go. So what I want to do over here, we look for stereo A. I have the, oh, that's fantastic. So we go here. This is the solar wind. Take a second to load. So what we look for when we see seismicity is we look for phi angle shifts. When it goes from one side of this range down to the bottom, that's a change in the phi angle of the electric circuit that emanates off the sun. It's an electric current sheet. It comes off the sun in waves, and those waves get larger and larger. The bell curve gets bigger and bigger. So these waves are always hitting the earth at an angle. So when it comes down to the bottom or the top of one of the bell curves, that's what we call a phi angle shift. So the angle of those forces changes. And when that happens, that usually has an effect on seismicity worldwide. However, this is not what I wanted to look at. So let me just bear with me here. Go to my bookmarks, show bookmarks. We go over here to, where is ISWA? Wow, I'm doing a bad job here, guys. Sorry. Integrated space weather analysis. There we go. So if we go here, we can have, so the Earth has two satellites that we call stereo A and stereo B. We like to think of it as stereo ahead and stereo behind. They might even be called that, actually. So I'll give this a chance to load up. So basically what that is we have a satellite that's way off to the left of Earth if you're facing the sun, and then another one that's way off to the right. And what this does is it gives us a view of the sun at an angle so that on stereo A, we could see the sunspots and the coronal holes that are going to be facing Earth in a couple days. And then stereo B, or behind, are the things that have already passed facing Earth and are going around towards the back part of the sun again. Oh, wow. Everything is different here. So stereo A, stereo ahead. That's the coronagraph. That's not what we want. We don't want SOHO. God, everything's different here. So I guess we'll just have to do this later unless I could find it here. Nope. Not quite. Coronagraphs. That's not what we want. Okay. We'll just have to look at that some other time, I suppose. So I'll get a, wait, do I have it in here? Boom. Is this it? Anyways, so I guess we'll just have to find out later whether or not this is a large coronal hole turning in. Because again, these coronal fields are kind of going to block out how dark these actually are. Like, for example, up here, this is actually really dark if we were to look at it straight on. But the coronal fields emanating out here kind of obfuscate the view, so you can't really tell how dark that coronal hole is or if it's one. But we can also come here and kind of see, maybe, you know, this is the one facing us right now. You can see it looks like a different shape. So hard to tell, but I actually think this might not be a coronal hole. Either that or it's a separate one, but it's an extension of this coronal hole right here. So low pressure cells still have a little bit right here. This is the only place we're seeing low pressure cells is in this area right here. But then when we look at the earthquake map again, where are we seeing this cluster of new earthquakes happening, right? So something to think about there. So coronal holes, we have other low pressure cells to look out for. This whole area right here, which is, north of the Philippines off the coast of Guam and stuff, and, southwest of Japan, this area right here. And again, these things move around frequently, so you have to kind of stay updated on this stuff. And then we're seeing, look, let's see. So for example, in Alaska right here, we have this low pressure cell, right? This high pressure cell is feeding all the way into here. It comes all the way into here and then into this area right here. And if we look at the earthquake map, what's going on in Alaska, right? Not much going on in Alaska, but what we do see is right there where there's low pressure cells, right near where those low pressure cells are. Remember, this is plate boundaries right here. See, this red line is a plate boundary. Low pressure cell right there. So that's, part of the equation on how we forecast seismic events here. So if this right here starts moving closer to the coast of Mexico right here, we could see something in Mexico, maybe even the Baja area. So that's basically, I think that's about it. That's all I wanted to go over today. Whenever it's red like this, just so you guys know, it's another good thing to know, is that whenever you see a red dot, it's like, why is that a red dot? It's a 1.5. It's tiny. A red doesn't mean how severe it is. It doesn't have anything to do with the magnitude. What it has to do with, I believe, is that a red dot is when someone reported that they felt an earthquake and or there was damage reported. So I highly doubt there was damage reported in this 1.5 area in the middle of a field. in the middle of a farm. I seriously doubt this did any damage, but somebody there might have reported that they felt it. And if anybody reports that they felt an earthquake, the dot will turn red. When there's a cluster of quakes like this, which one turns red is kind of arbitrary because, you know, they based it on when it was reported, but that's okay. When was a report received, and then was the report made right afterward? Was it made half an hour later? It's kind of hard to tell. So it's a little not entirely accurate, but it's also not entire. It's really not that relevant. But just so you know, when you see red dots, that doesn't, you might think it has something to do with the severity or the magnitude of the earthquake, but it really doesn't. It really just has to do with reports of it being felt. Like you'll never see an earthquake like in the middle of the ocean right here. That's a red dot, no matter how big it is. And sometimes we see big ones. Sometimes we see 7 magnitudes, just like massive ones that occur beneath the surface of the ocean, like way, 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 way beneath the ocean. But nobody's around to feel it, so it's not going to be a red dot. Anyways, just wanted to leave you with that before we go. That's it for today. Let me know in the comments if you have any questions or if you have anything else you want to discuss or anything else you want to point out. I'd be happy to. And that's it for today. Quake.